Hello, my name is Mary Jo Fender and this is Math for Middle School. What we're going to go over today is what do points on a graph really mean? What you'll need for today is paper and pencil. Okay, let's take a quick second. Let's get ready to learn. Last week, we talked about what are the characteristics of a proportional relationship on a graph. And I have the two graphs from Let's Review from last week. And you'll notice the two characteristics are it has to start at the origin or go through the origin, depending on if our coordinate plane just has quadrant 1 or if it has quadrants 2, 3, and 4. So keep that in mind. That's kind of special when we're looking at just quadrant 1 or we're looking at all 4 quadrants. And it also must form a straight line. Now, be careful. There are some graphs that do look like a straight line, but their increments may be slightly off, and so it gives the illusion. So you might want to check that. In our second graph, you'll notice it doesn't start at 0, 0. It starts at 20. And that can tell us something very specific about a graph, and we'll discuss that in just a minute. So let's get started. What do points on a graph really mean? So you'll notice that we have our 4-quadrant graph in the corner. At the top right, we have quadrant 1, and it goes counterclockwise, quadrant 1, 2, 3, and 4. When we're working primarily in 7th grade right now with proportional relationships, we're only going to be looking at quadrant 1 because both of our numbers or our values are going to be positive. And quadrant 1, the x value and the y value are both positive. You'll also notice that in quadrant 1, our x is horizontal. Okay, this is for all quadrants, just not quadrant 1. And our y is vertical. Okay? Now, that tells us something about our points. When we look at that graph, we'll use our point 2, 4. We have a proportional relationship between the number 2 and the number 4. Now, I used Halloween as our example because it's coming up shortly. And you'll notice as I look at my graph, I'm going to go over 2, and that means I'm going to visit 2 houses. And then I'm going to go up 4, meaning each of those houses is going to provide a total of 4 candy. Now, or 4 pieces of candy. Now we'll need to remember our equation for constant of proportionality. Remember that equation is k is equal to y divided by x. And we're going to need to understand what is the amount or quantity and what is that label or what is that unit referring to for each of those numbers. And to get that, we're going to look at our axes, our labels on those particular axes. And you'll notice the y is vertical, so that is going to be the pieces of candy. The y, if you look at its label, is going to be the houses visited, or the number of houses visited. So when we take that and we plug in our numbers, y over x, we're going to say, okay, that's going to be 4 pieces of candy, and we're going to visit 2 houses. Now, this division bar or fraction bar, actually we read that as a per. So when we come over to our actual fraction or ratio that we've rewritten with our numbers, we're going to say 4 pieces of candy per 2 houses. Now, that might sound a little strange to you because we can simplify 4 to 2. It actually we can take it down to unit rate, and when we do that, we're going to divide both 4 and 2 by the factor they have in common, which is 2. and we can simplify that to 2 over 1. Now remember, when we read that fraction bar, we're going to say per. So we're going to start with our numerator. So we're going to say 2 per 1 houses. So 2 pieces of candy per house, or per 1 house. However that sounds best to you, it's both mathematically correct, but most people leave out the word 1 because it's per house. You make the assumption it's automatically 1. So let's take a look at what a graph would look if it's in a proportional relationship. Remember, proportional relationships, you must go through the origin or start at the origin, and it must be a straight line. Now, if we haven't gone trick-or-treating yet, we haven't gone to any houses, we haven't collected any candy, so that's our origin, 0, 0. So you'll notice I still have my other fraction, or my other ratio to create my fraction. So I'm going to put both up here. So 4 over 2 or 2 over 1 from my first example. And now we're going to do our 0, 0. Now remember that division line means per, so 0 houses or 0 pieces of candy per 0 house. Okay, we must have that, and that means we haven't gotten started yet. So let's continue. You'll notice that this is in a proportional relationship because it is in a straight line. So what that means is any number or any point on that line represents a relationship. So if we take a look, and we're going to put a dot here, this is our 1, 2, so that represents for every 2 houses, or for every 2 pieces of candy, I get it from 1 house. Or I can reverse it and say for every 1 house, I get 2 pieces of candy. This is our proportional, this is our K, our unit rate, and it is also our constant of proportionality. Okay, so the points on a graph can mean multiple things. You just have to remember, okay, what's my label on my X and Y, and how can I use that? So let's take a look at another one. We all know the story of the rabbit or the hare and the tortoise, or the rabbit and the turtle, however you want to say that. And you'll notice I have 2 points here. The first point is 0, 0. That's my origin. Notice I have a straight line, or what looks like a straight line, so until I can prove it otherwise, I'm going to assume it is. So at point 0, 0, this is going to be the start of my race. For this particular example is for the tortoise. Now you'll notice here's my ordered pair, 3, 12. So I'm going to go ahead and put it in my constant of proportionality fraction. So I'm going to say 12 on top, 3 on the bottom, or my numerator and denominator. So look on your axes to tell you what each of those mean. So the 12 is going to be my distance that the tortoise traveled, and the 3 is going to be my time. Now, you don't want to say distance per time. You really want to use the units that they're talking about. So my distance in units is going to be feet, and my time is going to be minutes. So when I say 12, I'm going to use the label feet, and when I say 3, I'm going to use the label minutes. Remember that fraction bar means per, so I'm going to say 12 feet per 3 minutes. Now that still sounds kind of funny because it's not in unit rate. So if we look, we know that the factors of 12 are 1, 12, 2, 6, 3, and 4, and 3 only has the factors of 1 and 3, so the common factor that I can simplify by is 3. So this will actually give me 4. This will give me 1. When my denominator is 1, that's going to be my unit rate. So I can say 4 feet per 1 minute or per minute, whichever sounds correct to you. Okay, so the tortoise is actually traveling 4 feet per minute, which for a tortoise I think is kind of fast. But let's go on. Notice this is a graph of the hare, and you'll see that it's not in a proportional relationship. It does start up 0, 0 because this is the start of my race. But you're going to notice this line right here. It has a constant speed. And that constant speed is 0 because it's not making any movement. So this is when our hare is at rest. He's not progressing any further in the race. And then you'll notice at minute 3, he probably sees the hare and goes, oh my goodness, I got to catch up. And then he takes off again. All right. So when we look at these points, 0, 0, remember that's our starting. We haven't done anything yet. And right here, our ordered pair is 1, 8. So that tells me that the constant of proportionality, at least for this particular point for the hare, is 8 over 1. 1's in my denominator, so I know that's my unit rate. So the hare is traveling, remember I'm using my units, not distance and time. The hare is traveling 8 feet per minute. And if we go back to the tortoise is traveling 4 feet per minute. So the hare is actually twice as fast as the tortoise, as we would expect. But then between 1 and 3 minutes, the hare is at rest, and then he takes off again. And you'll notice here, our ordered pair would be 4:16. So let's check and make sure if he's going still at the same speed. So 16 over 4, that can be simplified. Common factors 4, so that's going to be 4 over 1. So he's now at that point traveling 4 feet per minute. So he's actually slowed down from his original speed that he started with. Okay, so let's take another look. Now we're going to compare these two, because when we graph, normally we just don't use a graph and look at a line. We compare two graphs together. So we're going to compare our tortoise and our hare. Now you'll notice that at 4:16, at coordinate 4:16, the tortoise and the hare are at the same point in the race. So that's probably what you see at the picture right there, is the hare has caught up with the tortoise, and they're trying to decide, and they're trying to figure out, okay, who's going to win the race. So we can tell how fast each is going by figuring out the unit rate, looking at the points on a graph. We can determine whether they start, what their beginning is, what their constant speed is, whether they continued at a constant speed or, like the hare, decided to take a nap, and at any point in time at the same place, are they still dead head to head or equal. So let's take a quick review. What do points on a graph really mean? Well, we first have to look at the quadrant in which they come from. For right now, we're just going to worry about the first quadrant because both of our quantities are going to be positive. But if you look at the second graph where we actually have a line, we're actually going to be looking for what is the relationship between the x and y axis. So remember, our constant proportionality is actually going to tell us that relationship. We need to look at our axes titles. Depending on what those titles are, if they're generic and in parentheses it has a unit, it's going to sound better if you use those units. So for this particular graph, it's going to be feet per minute. any point on that line, and it's going to be easier for you to do right now if you choose the intersection where the graph is to determine those points. That is going to help you determine the relationship. Always remember to try to simplify to unit rate. If you can, it's going to make the most sense. That concludes our lesson for today. I really like that you joined me today, and remember to continue to practice on what graphs really mean and what those points represent. And it's been my pleasure for having you. My name's Mary Jo Fender, and have a great week, and I'll see you next week.